Hello student, today we will be solving question number 2 and the question states two charges of value 3 into 10 to the power minus 8 coulomb and minus 2 into 10 to the power 8 coulomb are located 15 meter apart. At what point on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. So we are given two charges Q1 and Q2, Q1 and Q2. Distance between the two charges is also defined here. We need to find a point of R1 distance where the potential will be 0. This is something we need to find, we don't know. And the other thing which question provided us is that potential at infinity is 0. So we know the value of Q is like Q1, first charge is 3 into 10 to the power minus 8 coulomb. Other charge is minus 2 into 10 to the power minus 8 coulomb. And the distance is 15 centimeter. As we solve, we will convert it into meter, and while converting it into meter, it will be multiplied with a factor of 10 to the power minus 2. So the term will be in SI unit of meter. The thing which I always state is that first step for our calculation, numeral calculation, should be conversion of all the units into SI units. All these units which define should be converted into SI units. First numeral rule is conversion of units all given into SI. So understanding how important SI units are very much important, and then remembering what all are the SI units, standard and the international units, which we have read in the chapter 1 in 11th standard. So that should be always revised. And this one thing which we make problem whenever we are solving, we make mistake in this concept only. We substitute the value, we do not include the given SI unit, and hence in the end of the answer we do not get the required answer. So the question is saying we are having a charge, one placed at a point, other placed at 15 centimeter apart from the last point. Now what we are taking this point at origin. We are taking this point at origin, so that this will come 0 and here it will come 15, directly to 15. So when we are taking this at origin, it will give us ease for the convenience, like we can do this thing. Numeral value calculation will be easy for us. Like if we are taking, this is our origin, okay, from here to here it is 15, from here it is 5, we go beyond this 40, okay, like that values will come. Now in case we have taken, this is our origin, and at 2 centimeter we started to take Q1, and at like about 15 centimeter away we have taken 2, but from origin what is the distance? 17 centimeter. Okay, so these two are different values. When we do the calculation of overall things, we have to then check this point, starting point also. So as there is no starting point given in the question, we will take this at the origin for our betterment, for our understanding, for our clarification and ease of solving the particular question. There is no such like boundaries that one should take it at origin only. This is for our own convenience. Now let's start solving the question. How we have to proceed with the question? We will take at origin, just check the pointer over here. Let's take origin O at the location of positive charge. This line joining the two charges is taken to be at x-axis. Negative charge is taken to be on the right side of the origin. This negative charge is taken on the right side, and this positive charge is on the origin. Negative charge and positive charge of the given magnitude are 15 centimeter apart. Now let P be the required point on the x-axis where the potential is 0. This is a undefined point. Like this point, we have given this point. We are assuming that at this point our potential is 0, and we will just simply check if this is x centimeter of distance. This distance from P to A will be 15 minus x distance. Okay, so if it is 0 over here, this value and this value can be equated very properly. See how we are solving. If x is the x coordinate of P, obviously x must be positive. There is no possibility of potentials due to two charges added up to 0 for x smaller than 0. We haven't taken this point on the negative axis. Just a minute. See. What they are saying that if they have taken x to be smaller than 0, this particular our q1 was here, q2 is over here, so this we have taken this point to be x and this point to be 15 minus x. This point we haven't taken over this side, because it is not possible outside this range to find the potential equals to 0. Like whatever value we will get for the potential for x and potential for 15 minus x or 15 plus x, whatever we are getting, these two will be the value which will have the same sign, and if there is a same sign, after adding up we will get some value of potential, not potential as equals to 0. Hence we are not going for the negative x-axis, we are defining the positive x-axis over here. Okay, now what we are doing here is, if x lies between O and A, O is a point where our positive charge is kept and A is a point where our negative charge is kept. OA, the whole distance is 15 centimeter, and from O to P the distance is x centimeter, and from P to A the distance is 15 minus x centimeter. See here, OA is 15 centimeter, then we have O to P x centimeter, and then from P to A 15 minus x centimeter. Now potential is given by the formula V equals to 1 by 4 pi epsilon naught into Q by R. So the potential due to OP minus the potential due to PA should be 0. So we will find for OP it will be given Q1 upon X, K into Q1 upon X minus K into Q2 upon 15 minus X. This is the formula which we are finding, and this potential will be equals to 0. The given potential will be equal to 0. So this is the formula we are using here. The value of K is 1 by 4 pi epsilon naught, which is kept over here. This K is like brought out as common. Then this is the value of Q1, this is the value of Q2. Here this is the distance which we have converted it into meters, and this is the left out distance, and the potential overall is 0. We need to find the point where the potential is 0. So x to be found and potential needs to be kept to be 0. Now this value is here in multiplication. When this value come to the right hand side, from there to here, it will be divided by 0. Anything multiplied or divided by 0 will give us the value of 0. Then only these two values are left. This value under the green bracket, and this value under the green bracket again. These two are left, which will be equated to 0. I will write over here for the better understanding. See, 3 into 10 to the power minus 8 upon x into 10 to the power minus 2 minus 2 into 10 to the power minus 8 divided by 15 minus x into 10 to the power minus 2 equals to 0. Now we will bring either or any of the two given statement to the right hand side, so that sign will change. This value is in negative sign, so when this will go over here, the value will change into positive, and we can equate these two value, because anything multiplied or divided by, anything added or subtracted with 0 will give the same value. So this same value will be given to us. Then here this will get cancelled, this will get cancelled. Only values which are left is 3 upon x minus 2 upon 15 minus x. Now what we will do is that we will equate these two values. Once equating these two values, we will get 3 upon x equals to 2 upon 15 minus x. We will cross multiply these two. It will give us 3 into 15 minus x equals to 2x, and then it will be 45 minus 3x equals to 2x. We will bring this 3x to the right hand side, as on the left it is minus. When it will go to right hand side, it will become plus 2x plus 3x. Now 45 equals to 5x, and hence x will be 9 centimeter. 9 centimeter. What is the other value? 15 minus x will be 15 minus 9 equals to 6 centimeter. So this whole calculation is given on the next page. We'll go to the next one. See, this is how we are solving. 3 by x equals to 2 by 15 minus x, and after solving in the series we will get x equals to 9 centimeter. Now if x lies on the extended OA, what we have seen is that this is O at origin, and the value of O is here Q1, which is given by 3 into 10 to the power 8 coulomb, and from here we have got the another value another value A. This is at 15 centimeter away from origin, 15 centimeter away from origin. Okay, so at this particular point we have found this is 9 centimeter and this is 6 centimeter, and at this point P, V will be equals to 0. At A, the charge which is present is minus 2 into 10 to the power minus 8 coulomb. Now if this line is extended, at this particular point, at point Y, we will find the voltage. Like we assume that at point, we assume at extended OA line at point Y, potential is 0. Potential is 0. In that case, this value will be some y value and this value will be our y minus y minus 15. Like when we are taking the extended one, the value which we are going to get is 3 upon x equals to 2 by x minus 15. How come this value came? See, understand it. I am making the diagram in the red. Q1 is over O and Q2 is over A. Extended point is over Y. We assume that OA, we do not assume, it is given in the question. OA is 15 centimeter. So, what is the value of OY? Do we know that? No, we do not know the value of OY. OY we have to assume. So, let us assume OY is x centimeter. X centimeter. This value is x centimeter from this to this. Now, what will be this value? Then this value will come the total, this total value minus 15 minus this value. This is 15 centimeter, right? So this total value minus 15 will give us this value, this y ka value. So AY equals to OA minus, OY is bigger, right? OY minus OA, that will come x minus 15 centimeter, x minus 15 centimeter. So similarly we have taken this particular equation over here. Hope you understand from where x came and from where x minus 15 came. Okay. Similarly, the way we solve this equation, we will solve it like 3x minus 45 equals to 2x. This we will bring it here. It will be 3x equals to 2x plus 45. Now we will bring this over here. 3x minus 2x equals to 45. 3 minus 2 is 1. So x equals to 45. So at 45 centimeter away from Q1. This statement should be made very much clear from where? Okay. From Q1. Value of Q1 is 3 into 10 to the power 8 coulomb. From Q1 at a distance of 45 centimeter, the V on extended OA line is 0. From Q2, that is minus 2 into 10 to the power minus 8 coulomb, at a distance of 45 minus 15, that is 30 centimeter, given potential V is 0 on extended OA line. And when the line is not extended, inside OA, from O to A, OA, from Q1 V equals to 0 is at 9 centimeter, and from Q2 V equals to 0 is at 6 centimeter. Okay. Now we will go through the conclusion. Thus, electric potential is 0 at 9 cm and 45 cm away from the positive charge on the side of negative charge. Note that the formula for potential used in the calculation required choosing potential to be 0 at infinity. This is only possible when we choose that the potential at infinity is 0. So that's all for today's class. This is the question we have done, and try to find the potential inside the given line and as well as on the extended of the line. So that's all for today's question and today's class. We'll meet in the next question with a new question, next class with a new question. So have a good day. Bye bye.